Come in, Houston. We're coming to you live from the surface of Mars. We've landed in the past 24 hours and have been testing out the battery system that has been designed to support our lives and research here.
Great. Let's just go through a rundown of what you've made so far and how it's running.
We have successfully constructed a battery system that helps pump oxygen to support our breathing. As you know, there were several design constraints that had to be kept in mind while creating the system, such as the Martian climate, what the battery was supporting, and transportation to Mars. I'm happy to report that the system was very successful in its implementation and followed all those requirements.
Just to double check that the battery is working properly, let's go over some of the requirements and how they're achieved.
Sure. So first let's talk about the most obvious of the requirements, having to work on the Martian conditions. Mars has a temperature that ranges from 0 to negative 60 degrees Celsius, which is an issue for a lot of materials used on Earth because of how cold it is. Another requirement is that the system must be able to handle the sandstorms, which have been recorded to have wind speeds as high as 60 miles per hour. It will need to be able to handle the high and low humidities as well.
So with a climate like that, what materials were used for your battery system?
Our approach was to find materials that could not only withstand the very low temperatures without becoming brittle and cracking, but also materials with a very low corrosion rate so that it wouldn't fail during these long sandstorms. We've decided to use Kevlar and graphite aluminum as our composite materials.
So these materials are also lightweight?
Yes, it was very easy to transport because we selected materials with an extremely low density. The graphite aluminum composite has a density of about 2.4 grams per centimeter cubed, and the Kevlar has a density of about 1.44 grams per...
Fantastic. So what were the components of the system that you now have up and running?
Basically, there are three components of our battery system. The first component is a series of batteries that are arranged in a chessboard manner. The second one is a power transmission system, which consists of wires and transformers. And the third component is a foundation, which has a truss structure.
Well, now that it is all set up, what kinds of failure are you preparing for and what measures have you taken?
Designed against the potential cracking of our composite material due to the extreme cold and atmosphere on Mars. What we have done is we cased the battery system with 2 layers of material so that in case that the outer layer fails, the other layer will provide backup until the top layer can be fixed. The first layer is the graphite aluminum composite with its high thermal conductivity and high strength to protect the battery from damage and help dissipate heat created by the battery. The second layer is a Kevlar, which has a high corrosion rate and performs well in cold temperatures and is therefore less likely to fail and crack during Martian's coldest nights. We also found that Kevlar degrades from UV rays over time, so to prevent failure from occurring, we have placed the battery system in a shady area. Additionally, the chances of lithium-ion battery exploding is 2.5 over 1 million. We have run multiple tests on our battery system to make sure our battery is not defective.
Great work so far. I'm excited to see how the battery system works out. Please keep me updated on the status of the system. I would like to speak with your team again in the near future. Keep up the good work. Houston out.